joining today. I don't know, Kelsey, if you want to do a quick intro.
Yeah, look, I've been around since 1999 in some capacity in this cloud game, or before it was cloud. A lot of people were just trying to figure out how to automate things or just get things done with computers in general. You're right in terms of the KubeCon being a part of two other people to start KubeCon. We wanted a community event around containers and Kubernetes specifically. It's something that I think the way open source has gone, we went from like source code to community real fast. And ideally, it's just not more, it's more than just the source code, right? I think it's the idea of people using this stuff in production, sharing what we know, and then filling in the gaps together. So, looking forward to helping doing that with Cloud Custodian. I can't believe you guys got this project off the ground, built a whole company around it, and now creating a community of your own. So, love to see it.
Perfect. Um, cool. So I think the first question I wanted to ask you was basically um, like you have a unique perspective, right? You started off in the financial services, you then joined a cloud tooling company, then you spent time at a provider itself, like GCP. So what are some of the lessons that you have learned along the way um, being a practitioner?
So for a lot of people that may not know, before I did any of these kind of corporate roles, I started a small computer store right outside of Atlanta. That's also one in the chat is from Noonan, Georgia. I lived there for a couple of years. And like most people, I just kind of learned what I could. Back then, we were moving Novell NetWare to Outlook. That was all the rave. And then, Linux was definitely coming out as a challenger to things like AIX and Solaris. So for me, I was kind of born in my career started in the open source journey as open source became mainstream. In many ways, so did I. One of my first set of jobs was in the data center, so racking and stacking servers, network switches, all kind of forms of automation. And when I get to the enterprise, I think things mature quite a bit, right? You can't go as fast. Every outage costs actual money, right? Production customers being impacted. There's this thing called compliance and security requirements. You can't deploy until midnight, and then it must be done by 6 a.m. because that's the only time you have for a change window. And then when you get into open source companies like Puppet Labs and CoreOS, and of course, before getting to Google, it was about building those tools. And it's building tools that people maybe have homegrown solutions for, things that you would write your own shell script for, but figuring out how to scale not best practices, but the practices to the broader community. What I've kind of learned is that innovation kind of happens from those people that operate these things in production. Like you said, we're seeing new projects coming from not just the vendors, but the people that are actually doing the work in production. And I think this is why when these tools launch, they actually feel like they're ready to go. They feel like there's a little bit of nuance covered versus like I don't know, maybe a prototype or a beta that's like, it would be good to attack this problem in this way. So I think that's kind of the big thing that has changed. We went from vendors selling the software to the community creating the industry standards that even the vendors eventually conform to. So it's been nice to see that full circle. Oh, I can't hear you. You're muted.
Sorry, my bad. I was saying from a cloud provider perspective, um, a lot of community members ask us, like cloud native providers have their own tool sets. Some of them are on the call as well right now. Like how do you, why you need third-party toolings, even when the cloud providers have a substantial set of tools that are continuously providing, upgrading, and all that kind of stuff too.
Let's just be honest. Like if you're a practitioner and you really ran infrastructure in production, you buy a bunch of hardware because you're never going to get another chance, right? You can probably get to do it every 3 to 5 years if you're lucky. And in those scenarios, what do? We just bought all that we could buy, and the upfront cost was negotiated by your executive team. Not what you just need, but what you can get between now and the 5 years. So if your app only needs, I don't know, let's call it 32 gigs of RAM, you're going to order a terabyte because you're never getting another shot. That has been the reality for a very long time. And so that means cost was just kind of pre-negotiated. Any overspending, any underutilization was just accepted as cost of doing business. So maybe you ordered $100 million worth of gear. Most people would say, look, that's good enough for the next 5 years. And ideally, it's a little bit more predictable. In the cloud, I think a lot of people have this idea that the cloud providers are being malicious. As someone who's worked at GCP for 8 years, I think the cloud is motivated not necessarily by cost management or observability or any of those things. Cloud is predicated on giving you what you asked for. And what most customers want is automation. They want multiple regions. They want features. They want them to alleviate the manual things that they would have to do or build for that matter. So that means everything is built for you to turn on really, really easy. Some things are meant to turn on, turn off really easy, but no one's going to make you do it, right? There is no world where cloud providers are just going to go garbage collect unutilized VMs because honestly, there's a divide between who manages the infrastructure and who uses it. And to be honest, cloud providers don't have the context. I don't know if you're going to use that VM or not. And we shouldn't be looking in that kind of detailed granularity. And so when you think about what you do as a platform engineer or maybe in ops or DevOps, you should have way more context about what an idle machine is doing or not doing or could be doing. And I think this is where, when you think about the type of tools you would want, um, they're probably going to be much more aligned to like those type of use cases. And remember, cloud providers can only go so far in their user interfaces. If you just look at like computing, VMs, maybe even bare metal, Kubernetes, maybe pass, right? Run this function, run this container. But they're not going to go much further than that, mainly because every company has a different way of doing things. Every company has a different concept of what they believe is good cost management or automation. And so, to be honest with you, all cloud providers just have to stop. And then the more flexible toolings are just kind of left to the community. We saw this with Terraform. You saw this with things like DDoS protection and reason why people put Cloudflare in front of their cloud provider. So this isn't new, right? We saw with configuration management. So it's not odd to me that we see most of these tools coming from the third-party ecosystems.
Great. And if you look at like open source community, right? Like Cloud Custodian and Stacklet have their roots in open source. Why an open source ecosystem is so important
I'm
as
gonna be
well.
honest, a lot of people think it's about the licensing costs, and that is a benefit. Like if you're just trying to get started with any of these tools, especially if you're cost conscious, like the last thing you want to do is go tell the company that we got to spend more money in hopes to save money, right? So I think just the ramp from a cost perspective, knowing that I can just kind of download this thing without necessarily getting into the deep licensing costs, especially as you're learning, is important. I think the other part about open source community is that you can change it. I don't think people realize how important it is to be able to use a platform that has like a plugin system or an extension system. And the reason why I think that part is important, when you download any tooling like this, there is no way it's just going to work 100% out of the box with no customizations. It just rarely ever happens. You tend to have to integrate to some bespoke system, maybe some niche kind of platform that no one else in the world uses because your company built it themselves. And in those scenarios, that's when you're going to probably have to write that little bit of glue code, that little bit of an extension. And then you're going to have to probably integrate with things like your CI/CD system and other command and control things that you already have. That's the other part that I think is important. And the last part is the community piece. And I know people hear community, and it's like, oh, that feels a bit cliche. Well, I come from an era where the only information you got about a tool or a product was from the official docs. That's it, right? If it's not in the official docs, you go nowhere. In this world, we typically see people are like giving talks about exactly how they're using this stuff in production, sharing what they were doing before and what they're doing now. The concept of a Slack channel just being people that wake up like you and say, hey, here's how we did it. Here's how you can do it too. And that's the type of thing that leads to a company like Capital One saying, hey, we had to build all this missing tooling and we're just going to share it with the rest of the community. That's something that you don't typically see in the commercial endeavor because things have to be commercially viable before they're community viable. And so the fact that we can just build tools for our own needs, because solving our own problems is the value. And then, of course, you get into the tail end of it is like sustainability. And I know this doesn't come up quite a bit. When I was at CoreOS and at Puppet Labs, I don't know how any of those projects we produced would have been sustainable without being able to work there full time. And I don't know if you all know this, but developers like to be paid to work on things like bugs, enterprise integrations to your like key management system and Active Directory for permissions and authorization. So I think what we see now, especially in the last maybe 15, 20 years, some of the most successful projects, we're talking about the ones that are huge scale, they need full-time dedicated people to make these things sustainable and reliable. So I think having all of that makes it all come full circle. So that's kind of my thoughts around why open source is about sustainability, extensibility, and just honestly being have more than just a few vendors or a few companies being able to benefit from these ideas and innovations.
Great. And then I think adding on to that, looking at the theme, um, a lot of people talk about governance, right? Like as an afterthought. And hey, you're a governance project, you need to govern cost, security in the cloud, especially everything is so changing so fast. Like, how important is governance in this aspect? How important is automation to governance as well? Should governance be an afterthought or baked into the process? Somebody told me everything in the cloud costs, right? So how do you prioritize something like governance when you're adopting cloud?
If we're being honest, governance is going to be an afterthought because most people don't even know if the thing that they're building is going to even work. Like most people don't know exactly how many machines they will need. Most people don't know exactly how many customers they're going to have. And I know we kind of say security and things like governance become an afterthought, mainly because we don't even know what we're governing yet. And that's why I think a lot of times if you try to be overly prescriptive, like, hey, before we use the cloud, we're going to define 100,000 rules and policies before we can go to cloud. And I think that's when most people never make it to the cloud because they try to over-engineer a thing they don't even understand. Like if you've never run into the cloud before, you have no concept of like how much a managed tail of certificates going to cost. You have no idea how many apps that will start and stop via a cron job that are going to spam an API that costs $1 every time you call it. It's almost like you can't ever do that. So I think there's a concept of when you think about governance, I would say if you wanted to simplify this and get everybody on board, just ask yourself, how should it work? Right? Maybe a simple question would be, what is our actual budget? Like, where's the point where we say we're spending way too much money and we should change our behavior? And so for some companies, that might be 10 grand a month. For others, it may be $100,000 a month. For some people, just sitting that threshold, like you have on your credit card or hopefully on your bank account, like if all your money goes away in like an hour, there's probably an issue, right? So you're going to have some type of cost management in play. So I think for most people, how should it work? Should we turn off our dev environments when they're not being used? If you just go through simple Q&A like that, especially over time after you've seen the application operate, then you can ask, how do we enforce what we want the environment to be? And I think someone in the chat kind of brought up the idea of like the chicken and the egg. It's 100%. And so to me, you'll never be done. I think you have to have this feedback loop. Hey, we just launched into the cloud for the first time. How close are we to our budget? Is there an opportunity to save money? Where? And I think if you just kind of keep that in mind as you go, I think you'll have a much better time at it. And the last thing I will say here is, I think engineers, we kind of got a little lazy. We've been so far from how much things cost that we just do stuff, right? Like, oh, I need another database for testing. I'm just going to start with the one that's the largest so I can see what performance will look like in production. Like, what are you doing? You're going to bankrupt the whole company. And so I think cloud brings it way closer to reality. When a CFO or some tooling sends you a bill and say, hey, your little experiment with Kafka and Haskell is costing us $100,000. We need you to stop. And I think that's the moment where now we can think about engineering in its complete sense. Remember, I think engineering as a discipline includes cost. When we say best solution for the job, typically monetary is part of that calculus and part of that engineering. So we're back where we need to be.
Perfect. And I think you talk about cloud costs, right? Like a lot of times there's an engineering cost as well, right? Like if you don't have that automation in place that automatically guides engineers, fixes that things automatically in our case. Open source is really not free. I liked that you mentioned that as well, right? The engineering cost, if you don't fix things up fast, engineer has to chase and fix it afterwards. If you can, highlight that theme as well.
Well, look, I think there's a lot of aspects here. Like the first time I think most people experience, even if they didn't do it consciously, auto scaling was like the first form of automated cost management that I've seen most people do, right? There's no way I'm going to just run at peak capacity 24 hours a day. It seems wasteful. It seems unnecessary. But I think the reason why most people started there is because the tools were there. Auto scaling groups in Amazon. It's almost like you couldn't go to a cloud provider that didn't have the concept of an auto scaling group. And so for a lot of people, that is the first form of engineering that was really closely tied to the concept of maybe cost management. I don't think people did it specifically for cost management. I think there were other bounding factors like you can't have 50 VMs right now, right? You can have things like stockouts, or maybe everything you need isn't going to be available in a region. Also, I don't know about you all, but when I started using cloud computing, the VMs were called ephemeral for a reason. They were not guaranteed to be there 1 hour from now, even if you were actually using it. So those things could actually go away for any reason. It was your job to spin them back up. So we got into much better behavior around making sure the infrastructure we need when we need it would be available. So I think it's much easier to kind of do this in the cloud, I believe, mainly because you can do benchmarks. What is our peak load? Look at your historical data. And I think it shouldn't take long for most engineers to figure out how much cost would be involved. And I'm going to try to give you one real world example. I remember when Lyft, the ride sharing company, went IPO, and I remember in their S1 filing, so before you go to IPO, go to the public markets, you tend to tell your investors like where your risks are and where things cost. They did a detailed analysis of how much each ride costs, including the infrastructure cost behind it. And for a lot of platform engineers, that may have been the very first time you've ever seen that granular detail about how much is technology um, included in the overall price of the goods being sold, in this case, a ride. So I think that shows me like that is a very good engineering if you're going to use an uncapped platform. Remember, most clouds are uncapped spend. So it's like going to the grocery store with no credit limit and you just fill up the basket and be surprised at the bill at the end. So I think most people now are starting to understand that you should think about resource utilization as a deep engineering discipline. And that could be as simple as just tagging things so you know who it belongs to. So when it comes time to shut things down and make a decision based around cost, at least you have the metadata to do it.
Yep, no, absolutely. And I know with AI also coming in the picture, right? Like how does it make things better or worse? And why do teams need to, go beyond visibility to action and prevention too, right? That's a question that we keep getting too.
I'm about to give you all the most efficient form of intelligence you can use. Just use your brain. You don't need AI to tell you to spend down resources you aren't using. You can use real intelligence, like your brain can say, hey, 50% of our infrastructure is literally doing nothing. Look, I gave it to you for free. Zero token cost. You don't need ChatGPT to say turn off things that you're not using. I'm going to show you a real world example. Like if you didn't need the light, you can just turn off the light and you can turn it back on. It's real easy. Like you don't even need all of these advanced tools just to do logical things. I think people forgot what it's like to be an actual engineer. There's this concept of design and planning. So even if you did use an LLM, let's just think about it for a moment. When you think about AI, there's a model. What is it modeling? And typically, if these things are going to be useful, you're going to have to give them the ability to perform action. So this is where maybe MCP comes into the equation. So what would an MCP server do? Right? You might say, well, we need an MCP server for AWS and Azure and GCP and Oracle Cloud. Okay, so what will the MCP server be able to do? Well, that's going to be a little bit more deterministic, I would say. That MCP server is going to make the same API calls you can make with your brain. Right? You can say Terraform, turn off the thing. And so once you have an MCP server that has the ability to take actions, for some people, MCP in our world would be things like Terraform or API or a command line tool. So, all right, so now we have the tooling, right? We know we can turn things on and off. The other thing that I think that's important for AI is like it needs to be able to make a decision. So typically it needs context. So when we think about what is context in our world, in the real world, context would be utilization metrics, things like tags. You have to give it context to say, this is a dev environment. You can turn these things off. This is production. Even if it's underutilized, we would like it to be over provisioned for stability reasons. All of this context is what you're going to have to do anyway if you want to use any AI effectively. And I'm seeing people skip these base steps and then wondering why AI isn't magic. AI isn't going to do any of these random things for you. So you're going to have to actually do a bit of design. You're going to have to give the AI context. You're going to have to hook it up to the right tools. And guess what? You could have done this 15 years ago. You could sit down with your team. You can call them agents. If that makes you feel better, you can look at your teammates as agents, right? Like these little sophisticated tools that can take agency over things. And you just come up with a plan. We're going to tag all of our resources so we have the additional metadata we need. We can give our platforms context, and you can do that however you want. And then once you have that context in place, I think tools like Cloud Custodian gives you the missing part of the framework. This is why I think a lot of people struggle. Maybe they're trying to use the wrong tool for the job. They're writing bash scripts to do cost management. They're trying to use Ansible to do cost management. Maybe they're trying to use Terraform to do cost management. Honestly, those tools are great automation tools, but they lack the context necessary to make these decisions. When we build these higher level platforms, what are they actually doing? They're moving us one step ahead of this and saying, you know what? We know how to execute tools. But what we don't know how to do is capture the context that drives the execution of those tools. And that's the missing component. For those that have never experienced these type of platforms before, it's almost like using Kubernetes for the first time. You give it a definition of what you want, and then Kubernetes can drive the state of the infrastructure there. We're just finally getting this for things like cost management. Now we can start to articulate our policies of like, hey, here's what the state of the world is. Here's what you can do under certain conditions. And then you kind of set it and let the system either drive it for you or remind you to push the button so you can get to the state that you want. I don't think you need AI for that. I do think AI can help you with that. So maybe AI can do a better job of gathering some of these metrics. Maybe it can do things like predicting, like, hey, given the right metadata, given the right observability data, it may suggest that you can turn off production, but it's guessing. Why guess when you can know?
Yeah, absolutely. And on the other side too, right? Like people are using more AI-based infrastructure because it's definitely harder to buy GPUs through NVIDIA, right? So why do you think in a world where the cloud spend is increasing with the use of AI, how do tools like Custodian and
Hey,
Concept?
look, when you buy like 50 web servers that like have 1 gig of RAM each, and you only got like 3 customers and you want to load balance across all 50 so you can look cool on LinkedIn, all right, you can do that. People are gonna be like, wow, you got a nice big infrastructure. You picked a really nice load balancing algorithm. Even when you do that, that cost might cost you, I don't know, 5 grand a month. And I look at your resource utilization, you're at 1% utilization, but you look really cool that you got your Kubernetes, you got all these things being somewhat wasteful. But it's only 5 grand, so no one's going to complain. Some GPUs cost 5 to 20 grand each. So you think that you want to do a little bit of model training in dev. Remember, the cost for dev is the same for production. So hopefully in production, you're actually making money from utilizing these resources. In dev, if you're making no revenue and you take the same behavior, you're like, ooh, I just saw a Keynote where they just loaded up their Kubernetes clusters with 50 nodes with GPUs in them. Oh, trust me, when you see that bill for $400,000, someone's going to be like, why are we paying all of this money? What are we doing? So the GPU workloads are some of the most expensive workloads we've ever seen. And I think for people that are familiar with the mainframe days, you know, that concept of time sharing, time slicing, we knew that the mainframe was so expensive that we had to do a really, really good job of sharing that thing to get the most value from it. If you're just going to have a bunch of GPUs sitting idle, you're going to be burning cash in a way you've never seen it being burned before. And so I think for people that are thinking about cost management for the first time, maybe auto scaling web apps wasn't it for you. Maybe a simple 3-tier architecture wasn't it for you. I promise if you got to ignore it all of this time, introducing GPU or AI ML based workloads, you're going to wish you understood these concepts of cost management and putting a policy into place just to make sure you're actually getting your money's worth this time.
Perfect. I know we have the last 2, 3 minutes. If there are any questions, we'll take them right now during the lunchtime as well. But just to wrap up, any closing thoughts around tools and communities around Cloud Custodian as a core project, why folks should be looking at them, and so on.
Yeah, look, I'll be back for in a couple of hours for the Q&A session at lunchtime. So if you didn't get your questions in, save them for then. I do think it's important for us to realize that the platforms are getting more powerful than ever. We're turning policy into automation, which I think is fantastic. But it's a discipline thing. If you're an engineer, I think at this point, if you're fearful that AI is going to just do all the start and stopping of infrastructure resources, what value will you add? The value you're going to add is turning what we want things to do, what we want them to be, into executable policies. So let's go from putting all this stuff in some wiki or some Word doc that no one ever reads. Let's convert that stuff into things that the platform can actually handle for us and just kind of mature a little bit versus hoping that the bill isn't too high at the end of the month.
Great, thank you.